Hey guys, in this tutorial I'm going to show you how to make a very simplified clone of the mobile game Jetpack Joyride using Unity. I think this is a very good game to clone as a first project if you're getting into game development or learning Unity, because it's a very iconic game and the main mechanic can be replicated quite easily. So here I've got a new empty 2D project. The only thing I've done is import this script inspector plugin. You can just use Mono Developer Visual Studio, but for filming video this is much better because it lags much less. First thing I need to do is save the empty scene that it gave me, that Unity gave me. I'll call it game, and I'll put in my player. So we can make a 2D object or a 3D object. Even though Jetpack Joyride is 2D, I'm gonna make a 3D cube, and the reason is I don't want to import any of my own assets in this game. If I use a sprite, I'd have to put in a PNG or something, but with cube I can just use the 3D model that it generates. So this guy's looking a little bit too fat for a player, so make him a little skinnier and move him off to the left side of the screen. Nice. So I'm gonna do the same thing or a similar thing to create my floor and my ceiling and make it really long. This will be the floor. And it's always good to name your game objects accordingly. So this is our player, this is our ceiling, this is our floor. Now if we play it, nothing is going to happen. What we want is to add some gravity to this player. And we do that by adding a rigid body. Oops. Need to name him player. Add rigid body. Not 2D. Well, we could use 2D. I'm working with 3D objects, so I'm just going to use 3D. Use gravity is checked. So now if I play, yeah, and notice he stops because these guys have box colliders on them. Nice. Now, it would be nice if our guy moves, and in Jetpack Joyride, when our guy moves, the camera moves with it. So we can do this very easily in Unity by just making our player a child of the camera and moving the camera. So that way the camera moves and it'll move the player along with it. Make a script for the camera. So we want inside the update, we update the X position. So I'll just say 5F and 0, 0. Now since update is called a once per frame, as it says over here, we need to make sure that this is a multiple of time.delta time. So that way our game doesn't change depending on the frame rate. We don't want our guy to be moving faster if our computer is really fast. So taking a look at this scene here, you can see that eventually, it moves off and then our guy falls down. Okay, so we need to move our tiles so that our guy doesn't just fall off once he moves to the end of the world. Well, how do we do this? The simplest way might be to just make the scale of the floor and the ceiling really, really long so that our guy never reaches the end of the game. But if you imagine that I was actually using an art asset and not just these squares, I wouldn't be able to just stretch the X, make it really stretched out in the X, because that would look terrible for the art. So I'm going to use a different approach. What I'm going to do is I'm going to duplicate the floor and the ceiling. And I'll move it behind the one I made initially. So since our scale is 40, this means x needs to be negative 80, which is, or, no, negative 40. Negative 40, so it lines up with the beginning of this one. Same here. So what was the point of that? Well, my approach is going to be, once our player moves near the end of the floor and the ceiling, I'm going to shift these two over to the front. And then this guy keeps moving and moving, and then once he reaches the end of that, I'll shift this one over to the front again. So we never really need to make our floor and ceiling longer. We just sort of keep shifting the one behind out over to the front. So I'm going to make a new script for this and call it map generator. And I'm going to make a game object for that as well. I don't have to, I could just attach it to any of these, but it sort of makes sense because this is a distinct feature. And it cares about these, so I'll make these a child of the map generator. Again, not necessary. And I want to reference all those prev ceiling, prev floor, ceiling, floor. Hook those up in the inspector, like so. And we also need to reference the player because we need to know when the player is near the end of our map. Save it. No, it's always, even script inspector is not as fast as I'd like it to be. So what we're going to say is once the player is past the middle of this current ceiling, current floor, we move the previous ceiling over to the front. So we care about the X. It doesn't matter if we use floor or ceiling, I'll use floor. I always forget this position here. Just store just store these into a temporary variable. So temp ceiling equals prev ceiling. And then we shift our current ceiling down to the previous ceiling. Now we need to up the X position. So we use 80 because to move from here to here is 40, here to here, it's 80. Run that again. Oh, this should be vector 3. New. And I forgot the transform position again. Okay, and then I need to set the current floor and the current ceiling to the temporary ones. So as you see, once our guy moves past the end, that previous floor and previous ceiling moved out to the front. Okay, so now it'd be nice if our guy sort of moves up as we press our mouse button down. That's the whole point of Jetpack Joyride. So I'm going to make another script called player and attach it to my player game object. So we want to listen to get mouse button, not get mouse button down. Get mouse button down would just be when you press it down, but we want it anytime it's held down. And 0 is for the left mouse button. If you're using a mobile, this would automatically translate to a touch event. So you could use it for both mouse and touch event. This get mouse button down. Now what we're going to do is we're going to reference the rigid body and apply some force when the left mouse button is held down. So rigid body, and we always get the components inside start, or well, you don't always do, but you can't reference it like before the script has started. So equals get component. We want to reference this rigid body. We don't want to use update. We want to use fixed update because fixed update is synced with the physics engine, whereas update is synced with the graphics rendering. Now we apply or add force. Vector 3, and we only want a y force because the jetpack brings you upwards. So 0 for x, and 0 for z. We need something for y, and I'm going to just say 50 because I tried this before. But we also need the force mode. Oh, I forgot a new. What are you going to put in for this force mode? So this is actually pretty confusing. You might not know what's the difference between these. Okay, so you don't care about, or we don't want to use impulse or velocity change. Like we could use that, but then we'd have to then take into account the interval at which this fixed update runs. This fixed update runs every time the physics engine decides to update itself. But we don't know what that interval is. It might be faster if your computer is really fast. And we don't want that to affect how our game plays out. So instead, we want to use these acceleration or force ones. And this takes into account the interval of this force update method. It takes into account that interval, so you don't need to modify your vector to take into account the interval. But which one of these do you use? And actually, it doesn't matter. I'm going to use acceleration. The only difference is that if you look at here, like if you use force, it will take into account this mass too, like F equals ma. I'm pretty sure if mass equals 1, it wouldn't even make a difference. But even if it did make a difference, I don't really care what I'm setting this mass to. So I'm just going to use acceleration and ignore it. So that's pretty cool, but we don't want our guy to be like rotating and all that. So how do we fix that? Well, constraints. We only care about the y position for this physics. That's better. Now, if you try this out yourself, you'll still realize that there's something wrong with it, and that's after you let go, your guy keeps floating up. In the game, Jetpack Joyride, you actually stop pretty quickly once you let go, and this is important for like user interaction. Like you don't want your guy to keep floating up and then hit an obstacle if you just let go. So a simple way to do that is just slow it down once the mouse button goes up. We're gonna make the velocity a quarter once it goes up. So that feels much better. But if you wanted to make it like super polished, you'd probably want to smoothly reduce the velocity somehow, maybe by applying another force that goes downwards once you let go. But this is good enough for our very basic game. Now we want some obstacles. How are we going to generate the obstacles? Well, we're going to do similar thing as what we did for these floor and ceilings. We're going to have a few obstacles on the screen. So I'll just put in 4 obstacles, say. And then once your guy moves past, you know, say like the second obstacle, that first obstacle, I want to move it to the end. And I keep doing that so that like there's an infinite amount of obstacles. So I'm going to do that in our map generator. One, obstacle 2, obstacle 3, obstacle 4. And I'm going to make these obstacles out of a prefab. Obstacle prefab. Now I need to make our prefab. So again, like with everything else, I'm going to make a cube. So this is our obstacle. Let's make them skinny, 0.2. And everything else we'll set later. So rename this obstacle. That's going to be my prefab. Now I can delete this now that I've made the prefab. So I need to initialize some of these obstacles to begin with. So my strategy is going to be, I'm going to randomize several different intervals. The first interval is going to be, what is the Y position of my obstacle? Well, I know that it can't be higher than this or lower than this. So I'm just going to set 2 public variables and we can play around with it inside the Unity editor. Public float min Y, or I'll say min obstacle Y, max obstacle Y. And what's another thing we want to randomize? Well, we want to randomize what's the distance, the spacing between 2 obstacles. So public float mins obstacle spacing, public float max obstacle spacing. And one last thing that I'm going to randomize is how long the obstacle is. If like you're looking at the actual game, there's many different kinds of obstacles, but I'm only gonna care about that like long electric zapping thing. So that thing, it sort of only scales in one direction. Like it's always a thin electric rod, and it's either really long or really short. So I'll call it min obstacle scale Y, max obstacle scale Y. And now I'll want some method for generating these, but to test our idea, like demonstrate what I'm trying to say, I'll just show you how to do it for the first obstacle in a concrete case. So I want to instantiate the prefab. And I want to set the position of that newly instantiated object. So what's going to be the X when I start off? Well, I don't want it too close to the player. If I just start the game and my obstacle is like right up to the player, that's going to be so annoying. So I want a player.x plus some number. I'll just say 10, and then I'm going to do the spacing. Normally the spacing would be between like 2 obstacles, but to begin with, the first obstacle, there's no obstacle before it, so it'll be, you know, player.x plus 10 plus whatever spacing I choose. And to randomize, you use random.range min obstacle spacing max obstacle spacing. Z, we keep that as 0, but y, that's going to be min obstacle y max obstacle y. So random.range min obstacle y max obstacle y. Transform that position here. Okay. So what am I gonna do with obstacle 2? Oh wait, no overload for method range takes 4 arguments. Okay. So what am I gonna do with obstacle 2? Well, I basically want, instead of this player.position.x plus 10, I want the position of the first obstacle. So it would be something like obstacle 2 is this. This would be obstacle.transform.position. Obstacle 1.transform.position.x. So you can already see that these two is like very similar, so why don't I make a method that does that? It doesn't need to be public. And we need to take in that initial, that reference x position. Copy and paste that. Place this with my argument, and then I'll return the obstacle. Now I can call my method for all of my obstacles. And 4. This. So that should be enough to generate my first obstacles. I just need to set in those values I put in here. So we can play around with this, but I've already tried it, so I know what is roughly a good value. Oh. We're missing these, this obstacle prefab. So we forgot to set the scale. Local scale. So we'll keep the X and the Z the same as the prefab. And then generate the Y. Nice. Now it would be nice if we had more than 4 obstacles. We already have everything for generating our obstacles though. So now we just need to do is shift it over like what we did with the ceiling and the floors. So what I'm going to do is check if the player.transform.position.x is greater than obstacle 2's x. And if this is the case, like above, we need to set temporary shift everything over. Whoops. Now we want to set the transform and the scale of our first obstacle to move it over, because like we're not just moving over the position, we also need to change the scale, the height, just like here. So we want to redo this stuff, but we don't want to instantiate it again because we already have a game object. So I'm going to make another method called setTransform so we can reuse this. No, it's just a game object. And we need the reference x. So do that like this. Set transform obstacle reference x. Now in my temp obstacle, I just want to set transform. And reference x is going to be obstacle 3, because that's the one that's right before it. And obstacle 4 is now my temp obstacle. Run that again. Alright, so we've got a bunch of different obstacles now. So there's one more thing that we're going to do before we have a playable clone, if you can call it a clone, of Jetpack Joyride. And that is, we need to handle collisions. It's very simple. We actually already almost have everything we need. So our obstacle, we need to set this is trigger here. And what that's going to allow us to do is for our player, since our player also has a collider, we can override on trigger enter collider, and since our obstacle is our only trigger, we don't have to check what kind of collider this is. We'll just assume that, you know, if we have this on trigger enter, game is over. Game over. Oh, should be bool. This isn't Java. So now, what are we gonna do on game over? Well, if you remember in Jetpack Joyride, our guy sort of like stumbles along after he hits the electric zapping thing. That's sort of complicated to implement, so how about instead we just freeze him? So we freeze our guy by doing is kinematic equals true, and that means we don't want it to respond to forces anymore. The other thing we want to do is to stop the camera from moving. So I made the game over public. I'm going to reference the player and only do this update if not player game over. Make sure to hook up that reference. And then if game over, we just want to click to restart. So input.get mouse button down 0, and can use the scene manager using Unity engine scene management scene manager load scene, just reload the scene again, not like the most elegant way of restarting, but very simple. So we died, click restart. And that is basically how to implement the main mechanics in Jetpack Joyride. Obviously, this is lacking a ton of features, but there's a lot of things you could add to it to make it, you know, a little bit closer. Like for one, you could keep track of how far you've traveled and keep like a score counter. Another thing you could do is, you know, make different kinds of obstacles. Maybe make, you know, one that spins or one that's like just like slanted or something. So many things you could do. But I hope that this gives you a starting point. And if you like this video, make sure to comment, like, subscribe, and I'll see you in the next tutorial.